Swayam Prabha. Digital India. Educated India.
So coming now from the concept of DevOps, we reached the concept of MLOps, and then now there is next concept of DeepOps, which actually involves deep learning. And since deep learning is involved, we would be having a lot of GPUs with us, right? So those GPUs can be of any make, anything, but DeepOps is basically an open source project, okay, from NVIDIA, which facilitates deployment of multi-node GPU clusters for deep learning and HPC environment in an on-premise, optionally air-gapped data center or in the cloud. So the idea is you can have a physical on-premise data center or basically in the cloud. So this is a open source project. Now this actually is used for managing pods on the DGX. So at present, if you are not able to understand the architecture of a DGX cluster, let's not worry too much about it. But let us try to understand that any node, which is a worker node, has to run some pod on it. Okay, it may use a GPU, it may not use a GPU, and that modularity of the project, okay, will be of lot of help to these administrators who actually maintain, right, this infrastructure and software. So this is the GitHub link to DeepOps. Now there are so many things which DeepOps can do. So it can do the job scheduling using Kubernetes, RAM. You can maintain the firmware of the DGX. You can do monitoring using DCGM and Prometheus and Grafana. So we will see this actually today, monitoring. And then you can do FileBeat, Elasticsearch, and all of this as to how do you log. Then you can maintain and manage various packages, okay, so on and so forth. So now this is the architecture. You have got the login node, you have got the management node, and you have got the Kubernetes node, and these Kubernetes node are actually a part of the compute node. So you will have the SRAM nodes, you will have Kubernetes nodes, because we know that any Docker thing which is not generated by Kubernetes is not going to be maintained by the Kubernetes cluster. So you can actually take a Docker image and run it, but if Kubernetes has to manage it, it has to be actually what to say, started or be done on a Kubernetes through a Kubernetes image, right? So something like that. So here I'm just going into the basic of this as to how DeepOps came into this thing. And now there is an idea of hybrid strategy wherein we talk of, let me see if, okay, so we have this augment legacy of HPC schedulers with new features. So we have cluster management services, we have Jupyter notebooks, we have deep learning inference deployments, right? So you have to do inferencing. Inferencing is nothing but whatever is being done by the servicing pipeline, okay? Or you need to actually deploy it. So we use TensorRT, and then so that basically means you should ensure how do you deploy. So we need to also see that how the data has to be kept in the same place. No need to have separate clusters. Free up deep learning researchers to do DL, not become DevCops or system admins. Why not run on Kubernetes? So these are all things which are still in discussion or debatable based on the flexibility of the system, based on how the user wants to use it and perceive it, right? So that is how it is. But the idea is that all of this are going to make our lives easy for maintaining things which we need to do. Okay, so we are talking of Kubernetes managing the cluster infrastructure. It can run some workloads. We will have DL inference tasks. We can run Jupyter notebooks. We can do multi GPU, multi node deep learning training, right? And we can do tensor boards. They can so many graphs, so many charts. Okay, all of this. So Scrum runs HPL workload, sorry, HPC workload, right? So these HPC workload traditionally are non-containerized workloads, and but nowadays you get a lot of HPC containers, right? So whatever people used to do, Gromax, this, that, everything, still you have got a lot of containers which you can use for that matter. Okay, so now it is changing a bit, so no issue on that part actually. So how do you actually stack up the software stack? You are trying to develop a hybrid Kubernetes and Slurm cluster. So you have got Prometheus here, DHCP, containers, Grafana, alert manager, Kubernetes, then Slurm, login node. This is your compute node or DGX or whatever. Then you have this management node. So something like this, right? So let us try to do some demo, and before that, just for people who want to understand, right, how do you actually develop your own cluster. So I'm just going in very brief as to how do you develop your own cluster. You should have a management node which actually has the OS installation and Kubernetes bootstrap. You have to install and integrate SEP persistent storage. Persistent storage is very important. And then there are container deployments. So you have this management node, you have the login node. There are various ways of trying to actually do OS installation and bootstrapping of the login node, and then the compute node wherein you need to install Kubernetes again and then bootstrapping it. So this is in brief actually what I thought. We will do it in the theory portion. Now let us go for the demo. So what we are going to do in the demo now today is I will show you two ways of trying to see the same type of the setup, right? We have actually one master node, two worker nodes, okay? And then we will try to do it from the standard CLI type of thing using the Kubernetes dashboard, try to analyze it, try to run a machine learning application wherein we're trying to do a machine learning application development, wherein by seeing the marks of the students, the previous performance of the students, we are going to predict as to what is his probability of getting placed, right? This is a small ML application which we are going to develop. And next we will see another type of a dashboard which is far more easier than the previous one, so that you can appreciate as to how this particular thing of Kubernetes, the GUI development, the real-time analysis, all is actually improving, okay, for us to be better deep learning scientists or programmers. So let us try to go to the demo. Let me just log on to it. Okay, so now let us try to see whether what dockers we have. Okay, what dockers we have. So yeah, so we have got so many Docker images, right? So what we are trying to do is we are trying to use a demo Docker, which is CHPC demo for machine learning. It has a tag VM. It has got its this image ID, right? And it was created 4 weeks ago, and this is the size of that particular CHPC demo ML. So how we have done it? We have accessed a Docker from this. We will share the link. We did some modification onto it and then tried to rename it and repackage it as a CHPC demo ML Docker. Okay, yeah. So the next thing is to see and run this Docker. So how do we run? We use this command docker run. GPUs all, these are the port numbers, localhost port numbers. Then this is forwarding, and then this is this particular program. Okay, which we need to run. Okay, so now what we need to do is try to understand and try to see excuse me, try to see a program to do some prediction, which basically is something like this. So the candidate, his gender, his marks, okay, and what has to be done. Very, very simple rudimentary type of stuff, just to show you people as to what are we going to do, right? So now let us try to run this program. So once we run this program, the probability, okay, for placement is 0.90234375. Now let us try to see this in the dashboards, right? Mhm. So the idea is that we are going to start, okay, the Minikube nodes as the three things. So what we have tried to do here is we have tried to just see, okay, that the Dockers which we have downloaded runs using a Python. Okay, now we are trying to link it up to these three nodes which we are running. Okay, so I hope it's clear that Minikube is a local Kubernetes which gives me the option of generating a master and two slaves or workers. Before that, I have my Python program which can do this prediction, right? So now I am going to take this Python program, take it as a Docker, okay, and then try to run it so that it is serviced for people, or people can access it when it is running, okay, on one of these worker nodes, right? So the idea is that when you work on a desktop, you can just run your program, see it, and then you tell that you will test it. So you give the input, it gives you the prediction. So you tell, okay, done. But when you're giving it as a service to people, in a sense that when you're trying to develop an application, trying to sell it or then trying to develop it for the use of people, then basically you need to actually give it as a service. So you'll have to deploy it somewhere. Right now, how are we going to deploy it? We are going to deploy it using cube control. See here. So this is actually the service being provided by the Kubernetes on that particular IP, cluster IP, right? So now we will run this and then try to deploy it, right? So we have created, we will try to see the deployment file now. So what does this deployment file mean? We are trying to deploy this. This is a kind of deployment. Metadata tells that it is some name by name placement app. Application is a placement app. The container's name is placement app, but this is the container which we have tried to take the image from. I have this limit of my memory decided, the CPU this much, okay, and then the container port on which this particular pod actually is supposed to be deployed, right? So this is what we have tried to do it. Now once we deploy it, we will actually make it available as a service, correct? So then we run this minikube service placement app, right? So now it's running. Okay, let us wait for some time. Mm-hmm. 1 minute. We got some error. Seems we have not been able to. Yes. I don't know why this has become so slow. We'll see the Kubernetes dashboard and see whether the previous one is running. Okay, so there is some issue with the TLS handshake. So let me just go to the next thing. In the meantime, we will try to debug it, but let us try to actually go and see a situation here. So once you do it using this, right, there will be certain issues like this cropping up. What is now actually happening is this cube control uh, has got some issues, right? So these type of issues to avoid, yes, so we will try to actually see that it is done, up and running. It takes time, so sometimes what happens is you are, I'll again connect it. Where is this? RX 34C6. Yeah, so this service placement app got created. We were running the same thing, but it was giving us the TLS handshake timeout. So sometimes it happens. But anyway, once we are able to do it, now, yes. So if you see this, we are able to run it in the default name placement space, right? The default namespace, this placement app with this particular target port using this URL, and then we have to actually do a tunneling for this service placement app to this URL, right? So we will now try to open this dashboard, okay, and see as to what we get, and then we will discuss. So what effectively happens is we are trying to do two things. One is the old URL, one is the new URL, and we will have to do the tunneling. So we will now try to run the prediction, okay, using that URL, because it will be serviced there now, okay. So we have changed this, and then we will now try to run it. Yeah. Mhm. We'll have to put that IP. Yeah, so now we will go to the dashboard and see as to the same result, right? Just running on Dockers and then running on Kubernetes, right? As a pod. Now, how will we get it, right? So we'll try to see this. Yeah. Very slow. Okay, so see here, if you see, if you see the workload status, there is one deployment, there is one pod, there is one replica set, and then if you see what are those, right? The deployments, this is the placement app, what is the status, when did it start, right? So what type of label it uses, which is the image you are trying to run on it, right? All these details you get. Similarly, if you see the nodes, right? So yesterday we saw that there were three nodes, right? The one is the master, there are two worker nodes. So if you see now this mini cube, which is the master node, you have got details about this, right? The CPU, the memory, and how many pods it is running. Now, if you go to this worker node, okay, minikube M02, again it has got two CPUs, right? So many pods running, okay, so much memory allocated and stuffs like that. And then if you see this minikube M3, it again has this, okay. So this is the Kubernetes dashboard. Now, before we end today's lecture, maybe I will take 5 to 10 minutes more. I will show you another very good GUI, right? So even if you're not understood it totally, at least you should be in a position to understand that there is a node. On that node, you are running a pod. That pod runs a Docker. It can be any application. So for the time being, it is a machine learning application, which we saw. Now, when you see the dashboard, it's not that user friendly in a sense that you will have to scroll, you'll have to see everything. Now, I'm going to show you another way of seeing the same thing, right? Which is one of the very, very newest and the latest things, which is called as Lens. Now, this helps me to actually see my cluster information in a very, very user friendly way. For example, it shows me the master, what is the CPU utilization, how much memory is being utilized, how many pods are running, right? And how much of the memory in real time actually, how is it being utilized, the CPU performance, or how is CPU actually being used, right? So usage wise on the master, if you go to worker, again you get the information about how what is the utilization of the CPU, how much memory is being utilized, how many pods are running, right? So if you see this is a better way of trying to understand it in a better way, right? Here also you can see three nodes. One is the master node, one is the worker node, another one is the other worker node. And if you see this, you can work at the shell prompt of that particular node, right? So let us try to understand this, how it will be useful, okay, in your days to come when you are trying to use it, right? So you have actually entered the node minikube 3 now, right? I'm not using it at present, but I'm just trying to tell you the facilities available in this. If you see the jobs, okay, let us see the pods. We have got two pods running. I'll tell you what are those pods actually, okay. So one is a static web, which is this Nginx thing which we saw in the previous this thing. So if you see the Nginx thing, let me just show you that. Yeah, so see, this is running on that particular pod, right? So I will tell you what that means, okay? So this is actually getting serviced on the local host. It's a web server installed, okay? And it is running in this pod. This is this pod, okay? This particular pod. If you see this, how much CPU utilization, what is the network it uses, what is the file system, okay, where what are the ports on which you can view it, what is the status, right? All of this is available to you, okay. Similarly, this is Jupyter notebook. So this Jupyter notebook is running on node 3, whereas this is also running on node 3. It's not necessary that it has to run on node 2. It has actually allocated, right, based on some decision which it makes, okay. This is also running on node 3. So if you see this memory, file system, the CPU, okay, how it's running, ready, at what port. So you'll see that also. But before that, let me just tell you, if you want to create another pod, right, you have this resource, right, creating a pod, and then you can use deployment, you can use something. So I'm just I'm just showing you this, that this is the API version, right? YAML file, this what type of deployment, name I have given, which is the image it is running. See here. So this is a Docker image, right? So I can actually, when I'm trying to run the Jupyter notebook, okay, I will put the Docker image, which actually has a Jupyter notebook, and then I actually create it. I can create another Nginx now. Okay, I don't know why it's coming. See, resource Nginx development deployment successfully created. So see here. Now I suppose by mistake I clicked it 3 times. Maybe I don't know. So it has created 3 instances, right? And it's creating a replica set also of it, and it's pending. We'll wait for some 2-3 minutes, then we will see that it will actually, all the 3 of them will be running. And if you see here, this Minikube, sorry, this particular deployment is running on node 2, and this is running on node 1 now, okay, or the master node, okay, and this was running on node 3. So this also is now trying to run on node 3, and if you see, all of them have the status now running. So you can actually see that Jupyter notebook is running. You can go to the shell, so you can go to the root of that particular container. You have got all of these files and folders there, and if you see this Jupyter notebook, it's here, it's running on localhost, okay, with this. So let me just try to connect it. Yes, so it will open, it's initializing. So this is how actually it's going to happen. So my Jupyter notebook is running on node 3. You can attach a pod to a different this thing, you can shift it, you can see the logs, and if you see the logs, you will try to know, right, as to how much I have run it and at what particular port it is running, okay. All of this actually can be known. So let me just show you that, and then most probably that is what I thought I will share it with you today. So you can actually create, okay, a resource, okay, by a template. And if you want to see how we did it, so you can see the image which we pulled. We pulled the Jupyter notebook, minimal notebook latest from that, okay. That's how actually it has been done. So I hope this is a bit of idea to you, because from tomorrow onwards we'll be developing your own applications, right? Deep learning and machine learning applications using PyTorch, using TensorFlow and all. So ultimately, once you develop those type of applications using Dockers, then you can actually put into the pods and do the things very easily. You can actually do use such templates and do things very easily. Okay, so that's it. Thank you so much.